Let's find out how do we solve this AP question. If the sum of first p terms of an AP is the same as sum of first q terms, then show that the sum of first p plus q terms is 0. Now we know that the sum of first n number of terms of an AP is given by the formula n by 2 times 2a, where a is the first term, plus n minus 1 times d, where d is the common difference. So what is given to us is that the sum of first t terms is equal to sum of first q terms. Now what will be the sum of first p terms? So instead of n we will replace it by p, right? And similarly sum of first q terms we will replace n with q. So let's first find out the sum of first p terms. So it will be simply we are going to replace n by p. So we'll have p by 2 times 2a plus, now n is p, so it will be p minus 1 times common difference. So this is equal to now q by 2, which is sum of q terms, 2a plus q minus 1 times d. So these two are equal. So the 2 and 2 will cancel out. And now let's open the brackets here. So it will be 2aq, 2ap, so 2ap plus, now I'm going to multiply p by the terms inside the bracket and still keep d outside. And why we are doing that, you'll see that in a minute. So it will be p square minus p square minus p times d equal to, we'll do the same here. So we'll get 2aq plus, we will have q square minus q times d. Now we want to find out the value of d in terms of a, let's say. So what we are going to do is we are going to get this term over here, this d term over here, and we'll get this guy on the other side. So on the left side we will be now left with p square minus p, then minus q square plus q, and then we will be having d over here, and this will be equal to 2aq minus 2ap, right? Because this term will now go here and it will become negative. Now from here we can rearrange this to say this can be written as p square minus q square minus p plus q, simply rearranging the letters, times d equals 2a, we can take 2a common and it will be q minus p. Or from here we can write it over here. Let's change the color so that we don't get mixed up over here. So now we can say d is equal to, so this number or this expression, which is 2a times q minus p, this entire thing divided by, we have this in the denominator. So now p square minus q square, we can write that as p plus q times p minus q, and then we have over here minus p plus q, right? Or we have d equals, so 2a q minus p. Now at this point you have to recognize there are too many terms in the numerator and denominator that has q minus p or p minus q. So let's see if we can actually make the denominator as a factor, and if there is any way we can cancel this part out. It seems like we should be able to do that. So then we have the numerator like this and the denominator here. So we can write this as, so p plus q times p minus q, and then this we can write this as minus 1 times p minus q, right? Because if we just write minus 1 common, it will be p minus q. If you open this, it will be minus p plus q, which is what we have here. Or now we can write the denominator as, so numerator will be 2a times q minus p, entire thing divided by, now here we can take p minus q common, so we will get p minus q like this, times, it will be p plus q minus 1. Now here we can write this as, now we have q minus p and p minus q. So we can write the numerator as, let's take minus 1 out from here. So it will be minus 2a. We can write this as p minus q now, divided by p minus q times p plus q minus 1. Now we can cancel p minus q, p minus q. So what we have here is minus 2a divided by p plus q minus 1. So I know that we are actually doing a lot of arithmetic algebra in here, I should say a lot of algebra. So let's see how it will actually help us. Now let's get back, let's clean this up and let's continue. Now, so we have found out that d, the denominator, common difference I should say, is now minus 2a by p plus q minus 1. This is what we have received. Now, what we need to prove is that the sum of first p plus q terms is 0. So similarly, using the same formula, so the sum of first p plus q terms will be simply equal to n, which is p plus q by 2, times 2a, where a is the first term, plus, now it will be n minus 1. So n here is p plus q minus 1 times common difference, d. Now instead of d, we are going to put this value here, the one that we actually spent so much time calculating. So we can actually write, instead of d, we can write this as minus 2a divided by p plus q minus 1. P plus q minus 1. So this should be the sum of first p plus q terms. Or let's try to simplify. So we will have p plus q divided by 2 times. Now here, this p plus q minus 1 and p plus q minus 1 will cancel out. So we will have 2a, which is this guy, minus 2a. And voila, this is what we have been trying to prove. So 2a minus 2 is simply 0. So now we have p plus q times this multiplied by 0 or 0. And now we have proved that the sum of first p plus q terms is actually equal to 0.